Okay, got that going. All right, so today we're going to talk about the SoftLayer API. I'm Christopher Gallo. I'm the senior API developer here. Um, so my responsibilities are to these three main projects. So sldn.softlayer.com, that's going to be our API documentation website. That's going to be where you want to go to answer most of your questions about how the API works. I've got a lot of articles, a lot of examples, and a lot of other things on there to help answer any questions you might have. I also maintain the SLCLI and the IBM Cloud SL tool, which are two different projects that basically do the same thing. Allow users to use the classic infrastructure or SoftLayer API to manage their account, basically. So in this class, what we're going to cover is how the API is designed, how to use it, how to read the documentation, how to make API calls. I'm going to talk a little bit about how to use the SLCLI and IBM Cloud tools to do that. I'm going to talk briefly about how to diagnose problems. I'm going to touch on the internal API, where to get help, and how to contribute back. So just a fair warning, this stuff is pretty complicated, but it's also very consistent. So once you start to see the patterns of the SoftLayer API, it should all start to kind of gel in your brain a little bit. And going forward, once you get that pattern in your head, using the API is pretty straightforward. The trick is, of course, getting all of it in your head. The first spot is pretty hard. So hopefully this class will help with that. Feel free to ask questions. I've got the chat open on a second window. So if you have a chat question, put it in there and I'll try to answer it. I do have a lot of slides to get through, so we'll see how time goes with that. If I'm not able to get to your question, I have a Slack channel, pound SL-API, which is where I like to answer any API related questions. You can also message me directly. And I also have a email distribution list. This is mostly for if customers need to ask me a personal question, an API question, I mean, since customers don't have access to Slack. But all that said, just learn what you can and try to play around with the API. Once you start playing around with it and seeing how it works, it becomes a little more clear. Okay, so the first step is authentication, which is one of the key things. There's a couple different ways to authenticate with the API, and it can get a little confusing because of all the different ways. So the first one, we got a classic API key. This is going to be a 64-character long string, and it's associated with your SoftLayer user. So you'll authenticate with your SoftLayer user, which is different than your IBM ID, and with this 64-character long string. Your SoftLayer user is specifically your VPN username. If you look in the portal, look under your user, you'll have a VPN user, and that is your SoftLayer username. This was the original way to authenticate with the API, and it's still around. The newer way is with the Cloud API key. These are 32 characters long, and they're associated with your IBM ID account. You can also use a token from your username and password, either from your SoftLayer user and SoftLayer password, which most new customers won't have that anymore, but some older ones still do. Or a bearer token, which you get from the IBM Cloud IAM service, which again, you use your username and password. It's basically how you log into the cloud portal. It's the same basic principle there. You get a bearer token and you use that to make authentication calls. I have a full article about all of this though on SLDN. It's under articles, authenticating the SoftLayer API. And it goes through each one of these, and specifically it'll tell you where to get the key from, like how to generate it, how to view it later, and that sort of thing. So if you have access to a customer account, I'd recommend starting here and getting your API key before you start doing any API calls. Okay, so let's talk about what an API call actually looks like. And the first part of it is going to be the URL. There's two endpoints which we can send API requests to, the public endpoint and the private endpoint. The public one is on the public internet, available to anybody. The private one is on the SoftLayer private network, so you have to have a virtual machine or hardware server on the private network able to access this one. The only difference between the two is that the SoftLayer resource metadata service only exists on the private endpoint. Other than that, they're the same. And this service specifically is for a virtual machine or hardware server to query the API and get information about the server itself. So it's really useful for post-provisioning scripts. Other than that, that's the only time you really see it. Okay. Once we have the URL, we need to specify the endpoint type and endpoint version. And there's 3 different types. We have REST, SOAP, and XML/RPC. The difference between these 2 is only in how you format the request to send in. As kind of this picture shows, each 3 have a different format, but they all kind of get chopped up in here and spit into IMS as your the important parts. Like you got the class, the method, the arguments, and all those things. So once it gets chopped up into IMS, all 3 of the endpoints perform the exact same functionality. The only difference is how you format the data. In this class, I'm going to be focusing on REST a lot, mostly because it's actually readable by human beings. These 2 have pretty lengthy API calls. I'll show you an example of them in a bit, but they're not really human readable and very verbose. We also have 2 versions. Version 3 you'll see a lot of, v3.1. The only real difference is that v3.1 has this SoftLayer search service and has some object mask improvements that are going to be largely unnoticeable except for some edge cases. So in general, both of these are interchangeable as well. Okay, after that point, the API is broken down into services, which will contain a collection of methods that do some action. And you can see a list of those in SLDN, right? Here is the whole list of all the services you can interact with. There's a whole bunch of different kinds. So for example, if you want to do anything with an account, right, you've got all these account services to deal with. Virtual guest has the same thing going on. And here's an example of what that would look like. In the SoftLayer account service on the documentation, you have all these methods. Each one of these methods is a specific API call that you can make. It'll have different parameters it need to send in, different options you can specify, and different return data you'll get back. And generally, the name of the method should be pretty self-explanatory about what it does. And if it's not, it'll usually have a short description about what happens with it. And sometimes these are not always great, but it's what we have to work off of. Okay, once we have our service that we've picked out, we need to specify the method that we want to call. In this example, we're calling SoftLayer account get object. And to do that, just real quick and easy, we use curl. We specify our username and API key. We have our endpoint. We specify in REST, v3.1, the SoftLayer account service. We say get object. And then we get our object back that describes what our account looks like. So the only thing to watch out for is for XML and SOAP requests. The method part right here, that's going to go in your request object itself, not in the URL. Okay, some methods require what's called an init parameter, which will be listed in the documentation, so we can see that here. So here's SoftLayer virtual guest get object. And here in the required headers, we see it requires a SoftLayer virtual guest init parameter, which is telling us that to call SoftLayer virtual guest get object, we need to specify a virtual guest ID to go along with it. And here's an example of how we would do that. We got curl again, endpoint, REST 3.1, virtual guest. Here's the specific virtual guest ID I want to interact with, and we call get object. And then we'll get information about that virtual guest itself. And while we're talking about init parameters, I do need to mention that sometimes users will encounter unexpected 404 errors. And there's a couple reasons that this might happen. One, they might have just put in a bad ID. That happens a lot. Two, the ID, the virtual guest they requested information about, their user might not have access to it. Either because their user doesn't have the right permissions, or possibly that virtual guest has been canceled or reclaimed in some other way, and they no longer have access to it that way. So while we internally can see canceled virtual guest, users cannot. Once they cancel a service, it's no longer available in the public API. Okay, you can also control the format of the data that it's returned. That's why you'll see this .json at the end. With REST, that's JSON is going to be the default, but you could also specify text and XML. Okay, we got a question. Where do you get that init ID parameter from? Okay, let's see. Where do we go? Okay, so usually what you're going to do is start on the account service. So we were doing virtual guest, right? So get virtual guests. So SoftLayer account get virtual guests is going to return us all of our virtual guests. And in that information, we'll have the ID. So let's do a quick example. Okay, so here's what I'm doing. I'm using the SoftLayer CLI. I'm going to make an arbitrary API call on the SoftLayer account service. I want to call get virtual guests, and we'll talk about object mask in a minute, but I'm just asking for the ID and hostname back. And so here we have a list of the virtual guest on my account. This ID right here in this field is what the init parameter is looking for. So if we would do, we use the virtual guest service, get object dash ID equals, just pick one of these. And we can see we got information about that virtual guest. So that's where the ID comes from. And so for every service, the IDs are going to be different, right? So if we wanted to get a hardware object, we'd do SoftLayer account get hardware, which return all our hardware objects. And it's basically the same pattern. But the IDs returned here would be hardware IDs and not virtual guest IDs, right? So again, I got a list of hardware, a list of IDs, and these IDs might overlap. It's not likely to happen, but I could have a hardware and virtual guest with the same ID, but because they're two different objects in two different tables, I'd use that ID in the different service, if that kind of makes sense. But in general, if you want to find an ID for something, the SoftLayer account service is largely where you will look at first. Okay. Okay, some common API errors I want to talk about a little bit. So the first one is this authentication header's not found. I get people asking me that somewhat frequently, and it's always the case that they didn't put in their headers properly. So either they're mixing and matching their username and API key. So like they're using a SoftLayer username, but an IBM Cloud API key, or they've got some weird characters in it. So you just got to double check that what you're saying in it is correct. The 404 error, which I already talked about, basically just make sure user has access to the resource exists, and it hasn't been canceled. This one's kind of like a catch-all exception, and you'll see this one with probably very frequently. The SoftLayer exception public internal error. That just means something weird went wrong, and the API doesn't know what to do with it, so it just gives you this error. A common cause of this, though, is maybe you're requesting too much data from the API, and you can get this error. Or something else weird has happened. Like I'll see it sometimes with like SoftLayer virtual guest reboot or power off. The hypervisor itself might not be able to power off the virtual guest, so you'll get this error back sometimes. And those sort of things. The last one is SoftLayer exception web service bad request. What this one is telling you is that the API couldn't parse what you sent in, and it couldn't execute your request at all. So it didn't even get past like the first layer of the API. So with this one, a lot of the case is that your object mask or object filter might have some either weird or unescaped characters in it that you just need to check on. Okay, so here is an XML API example. I don't really expect you all to remember this too much. And I've got it written down on SLDN anyway. But here's what a request would look like, especially if you wanted to reproduce it manually. So we're going to use curl. We're going to -d to post in the data. This @ symbol means we're going to use the data from a file, because putting this all in the command line would be a little too much. So here's the file that we're going to use, which is all of this data right here. And we send it into this URL, which is, again, we got our URL. We're saying XML RPC as our type, v3.1, and the SoftLayer account service. As mentioned earlier, we don't put the method in the URL here. However, the method does get specified here. And we've got our parameters, our headers, our authenticate header, which is our username API key. We're having an object mask header as well, which is here. And then we close it all out, and that completes our request. This is what our response would look like. Again, just a pretty standard XML response. SOAP, almost the exact same thing, except instead of just a generic XML envelope that we're sending in, we've got all the SOAP data types and parameters listed out in here. And that's what a SOAP response would look like. Very similar to the XML one, just with all the SOAP junk in it. Okay, REST example is a little more readable. Here we specify our username and API key with -u. We specify any parameters with -d, which is going to post them into the API. We've got our URL. We say REST v3.1 service, init parameters if we need them, method name, object mask, object filter, result limit. And I'll talk about all three of these in just a moment too as well. And putting that all together, you get something like this. Okay, simple API call with the CLI tools. I just showed you that a minute ago, but the CLI, SLCLI, and IBM Cloud tools are a great way to make API calls without having to mess around with curl or any of those object mask type stuff. So let's look at this API call again. I'm going to add these 3 V's, which is going to tell the SLCLI to print out debugging information. And format equals JSON is just to tell it to output in JSON format. Okay, so we've got all our data splashed out here. But what you're seeing here is exactly what the SLCLI is doing, right? It's telling you the URL it created, the data, whoops, don't want to do that. The data it got back, this big URL, and this is it printed out nicely. And at the bottom here, we've got a nice little curl command that we can use, which is pretty handy anytime you want to make the curl call yourself, but don't want to have to type out the object mask and put the URL encoding and all that stuff in there. The IBM Cloud tool does almost the exact same thing. So it has the same command. It's IBM Cloud SL call API. And it takes in almost the same format. The only small difference is if you want to specify an ID, you use --init instead of --id. And the parameters are specified a little differently. Like with IBM Cloud, you specify them all as one object, whereas with the SLCLI, you'd specify them like each one after the other. Do I have a good example of this? I don't. But that's all right. So you'd specify them just one after the other in SLCLI. So that's the only big difference between the two. Both of them can make arbitrary API calls for you without having to mess around with curl or Postman or anything else like that. Okay, some API gotchas that I see a lot. So when you have a method that takes in parameters, they must be sent in this following format. So it's going to be a JSON object. This parameters bit is required, which is going to always be an array, no matter how many objects it is. And each one of these entries in the array is going to line up with an entry in the documentation. So to show you that, let's do, okay. No, not that one. Okay, so on DNS domain, we have like create a record, for example, which takes in 3 parameters. When you send those in, it'd be all this to start off with. Then the first string would be your host. The second string would be your data, and the third would be an integer for your TTL. At no point would you put the parameter name in any of this. I see a lot of users do that and wonder why it doesn't work. It's because the API is thinking you're sending in the literal string host as the host value, and that's not quite right. So just be aware of that. That's kind of one of the big things that is a little confusing because they are named here, mostly just so you understand what they're there for, but you don't send in that name with the API request itself. One thing to watch out for is XML RPC. Due to just the library we use, I guess, it returns integers as 32-bit signed ints. And so at certain large numbers, that rolls over into negative numbers. And unfortunately, we've got quite a lot of IDs that have approached that number. So I know for invoices and billing items specifically, like their IDs go over 32-bit ints. And if you use an XML RPC, you'll get those IDs back as negative numbers, which is not great. The only way around that is to use either the REST or SOAP endpoints, unfortunately. Another thing is, we're going to talk about this when we talk about object masks in a minute, but adding local properties to a mask removes all the default properties, which is usually what you want to do anyway, because that trims down the amount of data you get back from the API, which is a good thing. Because it's very easy to request too much data from the API. The API is very powerful in that it lets you traverse basically every single object with a single API call, but the database can't always handle that. And you'll get errors if you try to do stuff like that. It's also better to make a lot of small API requests than to make one big request. So instead of asking for every single bit of information about your account, it's better to split that up into multiple API calls. So instead of getting in one API call all your invoices, all your billing items, all your virtual guests, all your hardware servers, et cetera, each one of those as a separate API call would make it perform much faster. And I'm making this statistic up, but 90% of the API is going to follow the patterns I'm talking about. But you got to watch out for the 10% that doesn't. And I don't have any examples offhand, unfortunately. It's just that when you come across them and you wonder why it doesn't work, sometimes you just need to take another look at the documentation and try to figure out what's different about this API that you're using other than everything else. But for the most part, for most everything that you're going to be doing, it's going to follow all these patterns that I'm talking about. One thing to not get confused about is URL parameters and method parameters when using the REST endpoint. So URL parameters go in the URL itself, and these are going to be your object mask, object filter, result limit, and init parameters. Method parameters are going to be sent in as post data specifically. Some API call things like curl will do this if you don't tell it specifically, and I think Postman might do it too, is it'll convert some data that you want to send in into URL parameters, and the API is not going to really understand how to parse those all the time. So you just need to post them in when you're using REST. Okay, so that brings us to object masks, which are a key component to how the API works. And you specify them kind of like this. They're going to be an array-like string that's used to select which properties you want back in your response. So it starts off with this keyword, mask, and an open bracket, which specifies, here's an array of objects that I want. We've got object 1, which itself can have subproperties. So we open up an array here, which is what this bracket is for. We've got the nested property 1, nested property 2, which can have its own properties. So we, again, open up an array. And this is like the third level deep of this object mask. And we can keep going almost infinitely down into this ORM, these object masks. Because every property we select might have its own relational properties that we can keep going down and down into. But I've stopped at 3 just for this example. And we close off the brackets, add a couple more properties, and finish out the object mask. And when you send it into the API, it's going to be a string that looks kind of like this. You can have white space in your object mask, like spaces and new lines and that sort of thing, but you have to URL encode them. So I find it easier just to take them all out and have it look like this. Okay, so some concepts on how to understand object masks. The first one is data types. You can think of a data type as a SQL table because that's generally exactly what it is. So let's look at the virtual guest data type right here. So we have local properties here. You can think of local properties as columns in the SoftLayer virtual guest table. So each one of these represents a column in that table for the most part. Relational properties on this side represent rows in other tables that relate to the virtual guest in this example. So there will be an account row in the SoftLayer account table. There'll be some active network monitor and incidents in this long table, tickets in the ticket table, and so on and so forth. So basically, you can think of relational properties as the SQL join clause if you're creating a select statement for all of this stuff. And here's essentially what that would look like. So if we were going to use this object mask, we're going to call SoftLayer account get object. So let's look at the account data type. Okay, so this is all the properties we have available to us. It's quite a long list. You can see me just scrolling all the way down. So we could pick any one of these for our object mask. But I've picked these ones right here. ID, company name. Both of these are local properties. And virtual guest is a relational property. That relational property has two more local properties, ID and host name. And so the SQL that this will generate, essentially, this is not the real SQL, of course. It's just kind of an example for you. It's going to be select account ID, because we said this, account company name, because of that, virtual guest ID, because of this bit, and virtual guest host name, because of that one. We'll select that from the account table, because we're calling SoftLayer account get object. We're going to join the virtual guest table in, because of this relation, on account ID equal, on virtual guest account ID equals account ID. So this part right here, IMS knows that you only want the virtual guests that are tied to your account, so it adds this automatically. And it also adds this one automatically, where account ID equals active user account ID. That's why the SoftLayer account service doesn't usually require init parameters, is because it assumes the account you want to interact with is the account your username is associated to. Okay, so how would you build your own object mask? The first step is going to be find the data structure or data type that you care about. So in SoftLayer virtual guest get object, we see that the optional headers, it takes in a object mask. So we can use an object mask on this method. And the return value is where we're going to start our object mask. So let's bring that up. Okay, virtual guest. So we'll look at get object. Okay, so this is the method we're going to call SoftLayer virtual guest get object. Its return value is going to be this data type. And so this data type is where we're going to start our object mask. Next, we need to find the properties that we want to add to the mask. So in this example, I've found create date, hostname ID, and allowed network storage. These three are local properties, and this one is a relational property. And these all three are, these four properties I would consider to be on the same level of the object mask so far. And so here's what that output would look like. We use an SLCLI, call API, the virtual guest service, get account method. We have our ID for our init parameter and our object mask right here. So in our response, we have our host name, our ID, and allowed network storage. Allowed network storage, because it's a relational property, has some default properties that it adds in. Like we didn't specify any of these properties, but they got returned anyway, because that's the default for that relationship. So from there, we can find some more properties. So on the virtual guest data type, we'll look on allowed network storage. So here's this relational property that we were talking about. It's of a type SoftLayer network storage. So if we want to go into this property, we'd click here to the SoftLayer network storage data type. And here are all the properties we can select from here on out into this second level of the object mask. We open up that second level with this bracket. We specify the properties we want. These two are local. This one's a relational. We close out our bracket and we close out our object mask. And so the response this time looks a little different. We still have our host name and ID. and we have our allowed network storage. But this time we have a billing item, which since it's a relational property, has all these default properties on it. And we have our ID and capacity. And all the other properties from allowed network storage that we didn't specify have been removed from our response. So we can keep going even one more level. So this would be like level 3 of the object mask. So we'll look for billing item. Again, we see it's relational. It's got its own type. So we'll click on that type. And this is for the billing item itself. These are all the properties we can select again. Okay, so we got ID, hours used, and notes. All 3 of these are local properties. So at this point, we're done going deep into this object mask. And so our response will look something like this. Again, hostname ID, allowed network storage. We've got our billing item, but this time we've only got these 3 properties that I cared about, and ID and capacity. So as you can kind of see, it's pretty easy to go really deep into the SoftLayer API with an object mask. You can just keep selecting properties on and on and on. And at a certain point, which there's no real hard limit for this, but it basically depends on how long it takes the database to execute your query. At a certain point, if your query takes too long to execute or is too complicated or returns too much data, you'll get an error back from the API about it. And for some accounts, based on how much stuff they have on their account, basically, one API call will work for one account, which won't work for another account, which can be a little frustrating to figure out. But usually, if you ask the customer what their API call is, and then give you a really long object mask, chances are that there's something in that object mask that's tripping the API call up, and we need to look at the object mask itself to tune it down to what the customer actually needs from the API call, or split it up into multiple API calls as well. So here's kind of an example of that. So for example, I'm doing the SoftLayer virtual guest calling getObject, which is a simple call that we showed earlier, produces a very little amount of data. But my object mask, I'm having ID, hostname, I'm going into the account relation, and I'm going into the invoice relation. So this is going to get me one virtual guest, but all of my account invoices. So every single invoice that's on my account is going to be pulled in as well through this API call, which is usually not what you want to do. And as we can see with this content length, the response I get back is about 5 megabytes, which is a pretty large for a text file. Without the invoices property, our response is only 5,000 bytes, which is a huge difference. And that kind of just explains just how a little change can negatively impact how your API call performs. So getting too many objects can also be a problem. So here's a real simple API call. I'm not using an object mask, object filter, anything. I'm just calling SoftLayer account, get all billing items. It's a perfectly normal API call to use, and for most accounts, it probably works fine. But since the testing account I have is very old with a large number of billing items, I cancel and create stuff all the time, so it just generates a large number of billing items. Just making this simple API call, I get an error about it. Now I know that since my account has a lot of billing items, it's probably because I'm requesting too much data from the API. But customers will kind of have this complaint too because they're basically calling an API call with no options and it fails. And they think that's kind of an issue. And while they're not terribly wrong, there's also stuff they can do to fix it. And for this instance, if you just add object mask and just get the ID property, it'll get the command to work. And then from there, you can go through each invoice and get that in. You can go through each of those billing items individually and get information about them if you wanted to see all of them that were on your account. This header right here tells you how many objects were in that API response. And in this case, I have 128,000, which is quite a lot of billing items. But for some smaller accounts, this API call will work just fine without any issues. Okay, let's talk a little bit about object filters, which are kind of like the companion to object masks. In this case, they're going to be a JSON object that's going to use to restrict what data you get back from the API. Essentially, these are the where clause on your SQL query. They're going to limit which rows are returned to you. And one thing to keep an eye out for this is bad object filters. So for example, if you write an object filter for properties that don't exist, or if you format it incorrectly or something like that, the API will usually silently ignore that. So it's always a good idea to check to make sure your object filter is being applied properly before you assume it works. And there's also one other requirement. Not all methods take in object filters. You'll see that listed in the required headers section of the documentation. So this one takes in an object mask, but no object filter. And let's see. Get object takes in an object filter. So you'll see something like this. You'll see this object filter in here, letting you know that you can use one. Okay, so just like object mask, we have the concept of data types. The slight difference is that for most cases, the data type you're going to start with is at the service level, not the return level. So on SoftLayer account get virtual guests, we'll bring that up in the docs so you can see. Get virtual guests. Okay, SoftLayer account get virtual guests. Its return value is a virtual guest data type, which we've done some examples of already. However, if we were doing a object filter, we would start at the account data type level. So our first property in the object filter would need to be virtual guests. And this pattern is going to hold true for almost any API method that follows the get property pattern. Okay, so anything that looks like get and then a relational property is going to follow this object filter rule. So our virtual guest object mask would look like this. We got our ID, hostname, domain. Our object filter, however, would look like this one. So we start our object, we start the virtual guest property from the account data type. We specify our host name, and we specify that the operation is to be equal to test host name. And this is going to get all the virtual guests on my account that have a host name of test host name. There are properties you cannot filter on. Those are going to be count properties. So basically anything under this column, right? All these count properties. Most people don't use these anyway, I don't think, but you can't filter on them. Relational properties that return a basic value. So what I mean by that is like abuse email, you can't really filter on this. However, you can filter on abuse emails and the email property. So essentially with your object filter, you need to go through the properties, the relationships, until you get to a local property, and then you can filter on it. There's also computed properties. So these properties don't exist as a literal column in the database. Unfortunately, there's not really a way to display that in the documentation. So for example, the most common one is going to be fully qualified domain name. That does not exist in the database, and you can't filter on it because it's just a combination of domain name plus host name. So you can filter on domain and host name, but not fully qualified domain name. Also, any property in your object filter should also be in your object mask. Okay, so object filters control which properties are added to the where and order by clauses. So with this object filter by virtual guest hostname operation, it's basically adding this and clause to my SQL query already. And that's one other thing to note is that with object filters, when you add multiple properties to filter by, they're all going to be anded together. So that means if you want to search for virtual guests that have a specific host name, and you added a search for virtual guests that have a specific domain name, they would both have to be true, right? It's not either or, it's both of them. So if your host name was test and your host name and your domain was .com, you'd look for test.com basically, not testor.com. Okay, so step one, you got to find the data structure, which I talked about already. So for example, with SoftLayer account get virtual guests, you're going to start your object filter at the virtual guest property. For SoftLayer hardware server get active tickets, you start at the active tickets property. SoftLayer user customer get hardware, you start at the hardware property. So as you can see, all of these have get property name, and so the object filter you want will usually start at the property name, like get active tickets, starts active tickets, and so on. Okay, so you need to find the property you want to filter by, and basically that just ends up you having to go down through the object data types until you get to a local property that you care about. So in this case, we're going to filter by all the hardware that's on our account. That hardware should have a backend router, and that router should have a host name that equals bcr03.del10. This is going to tell the API to give me all the hardware on that router that's on my account. Okay, so step 3, you want to create the actual filter. So previously we had this operation and just a string. That tells the API to do an exact match. But you can also do some other matches as well. So we have this caret equals, which starts with this value, exclamation equals, which ends with that value, and you got a whole list here. You don't need to memorize these. I have these all on SLDN in the object filters article. And you can look through them there because there's a whole bunch of different options you can pick through. And the way you specify these is just in the operation string. You just start it with these characters. There's some complex filters. We got in, not in, or, and. And the way you specify those is with the operation, instead of doing a string like we did previously, we have the keyword in, not in, and, or. And those operations will also have options. The option will always be an array, and it'll have at least one property in it, which will have the properties of name, data, so that's required. Value is always going to be an array, and these are the values we expect. So what this query will do is get all the virtual guests whose host name is either hostname 1, hostname 2, or hostname 3. Not in is the exact opposite of that. Or is like in, except that you can do fancy operators like starts with, ends with, etc. And we also have the and property too. So if you wanted to have multiple matches for the same thing, you'd use the and operation. So this one says the host name is going to start with host and end with name. And so there might be something in the middle, might not, but that's a good use case for that. So date operations, occasionally you'll need to know this. There is a shortcut way. If you want a relative date, you can use this keyword sysdate, which will take the system date at the time you made the API call. You can subtract or add number of days, and that's a pretty easy format. Failing that, you need to use this Oracle notation for your date format. And the way you do that is, so we care about provisioning date. Operation is going to be between date. And our options, again, always going to be an array. This time we have 2 values in it. Their name is going to be date. The value is going to be an array of whatever date we start with and whatever date we end with. And the API knows which is start and which is end based on the order that they are in the array. Since this one's first, it's start. Since this one's second, it's end. Now, this date format is true for almost everything in the API except like the metric tracking data and the event log entries, because those are not actually housed in a SQL database. They're housed in like a big data database type thing. So they take a different format. I've got some examples on SLDN about what format they take. But basically, the date format you get back from the API is what you'll send back in those cases. Okay. So all the date operations, less than, greater than, between, and is. So that's pretty easy to get through. Another thing you can do with object filters is sort the data. And you'll do that with the order by operation, which will have options. The name will be sort, the value will be an array with which direction you want to sort, ascending or descending. So sorting is critically important anytime you use result limits, because the order that the entries come back from the API in is not always going to be guaranteed to be the same without an order by object filter. And the reason for that is that between API queries, the database might find a faster index to use for your results, and that different index might have a different ordering of your results. Okay, so if you don't specify this order by clause, and you get, let's say, entries 1 through 10, and then get entries 11 through 20, 11 through 20 might have some duplicates or overlap with 1 through 10 if you didn't use this order by clause. And that's something that's easy to forget. I forget it all the time. And so it's just something to watch out for. And also, you can't filter by and sort by the same property. So what I mean by that is, if you're having this order by on the ID property, you can't also filter by it. So I can't say order by ID, but give me ID equals something. Okay, so sort order, this isn't really used much, so I'm going to kind of go through it quickly. But you can order by multiple properties. You just have to specify the sort order and which number it is. So here, our primary sort order is provision date, and secondary is max memory. Okay, result limits. Like I mentioned them a couple of times, and it's a really easy thing to add in. You do result limit equals offset, comma, limit. The offset is going to be the record number you want to start off with, and limit is how many entries you want to get. So for example, when you have customers making big API calls that time out or take too long, adding the result limit and paging through the data is often a really quick way to make those API calls go faster and execute normally. But again, when you're using these result limits, always use an order by filter. And usually on the ID column, which is a safe bet for most cases. Okay, so adding all of that together would get you a curl command that looks something like this. So we got curl saying -s to suppress some of the curl's default output, -v to add in the headers, -g here makes it so that curl doesn't try to escape the brackets and the different types of brackets. So that way I don't have to have all these escapes all over the place. -u is our authentication. We do virtual SoftLayer account, get virtual guests. Here's the object filter that we want, and our object mask, and our result limit. And then here's what our result would look like. And here we have SoftLayer total items 1. So this is an important field when doing result limits, because this tells you how often you need to keep paging through the data. So if this was a number bigger than 10, for example, I'd know I need to make another API call to get the rest of the results. Okay, method parameters, I talked about a little bit already. But here's a concrete example for you. So create NS record, right? It takes in 3 parameters, a string, and an int. And here we have -d, our parameters, which is always required, our first string, our second string, and our end. And then we send it to software DNS domain with the ID and create NS record. And we knew we needed an init parameter because of this right here. And that will create an NS record for us. Some methods, like this one I'm about to show you. Let's see, what was it? Create object. Okay, create object. It takes in 1 parameter, which is an object in and of itself. So we look at this object, and these local properties are all the properties we can fill in. So we've got parameters again, which is our array, always going to be there. And this is our one object that we're sending in all of this. Here we've got names for properties like data, host, type, etc. And that's because this is a single parameter that's an object. So we have to name the object properties that we want, but not the parameter itself. Okay, so the SLC, I showed you guys that a little bit. I do have some documentation up here on SoftLayer Python Read the Docs that will go over how to use the SLC in a lot more detail for future reference. But basically, to call an arbitrary API endpoint, you just use the call API command. Your service, your method, your parameters. These are all your headers that you could use. And for debugging, again, you just add this triple V flag. And if you're using the REST endpoint, it'll print out this nice curl command for you. If you're using the XML RPC endpoint, which the SLC line also supports, it'll print out an XML payload that you can send in as well. Okay, so IBM Cloud SL, again, exact same thing, except for debugging output, you'd add IBM Cloud trace equal to true, and that will tell you exactly what API calls the SLC, the IBM Cloud tool made. Okay, so for debugging, to figure out what's going on with a customer's API request, the following data is going to be incredibly useful. So a code snippet, if they have one, that reproduces the issue. But if they can get it down to a pure curl call, that's like ideal. That way we know it's not a problem with the library or with whatever tools they're using. If they can say, I make this curl command and I get this error back, that's helpful. Knowing what API user made the API call is good to know, but never write down the API key, right? The customer should never give us their API key. We don't need to know that. Knowing if the API call worked in the past is also pretty helpful, especially if they tell us when it stopped working and when exactly it started giving it errors, because that way it's a lot easier to look it up in our logs once we have a time frame and user involved. Knowing the actual error we got back, whether it's SoftLayer exception, internal server error, or something else, right? It should be the error that SoftLayer gave back, not the error their application gave back. So I see a lot of customers, what they'll do is they'll say, hey, my application gave me an error, and they'll give me their application error. But it's not the SoftLayer error. Like the SoftLayer error is what we need to know. Okay, so since I'm running a little bit out of time, I'm going to touch very briefly on the internal API. So I do want to say that it's kind of largely unsupported in that if you want to use the internal API, you're going to be kind of on your own. I do have an internal SoftLayer CLI client that'll let you use your username, password, and two-factor token to make API calls. It basically works the same way logging into the internal portal works. You need to be on the VPN, you need to have your two-factor and everything, and your token will expire after a few hours. Okay, but you can still make simple API calls. And unfortunately, there's not really any internal API documentation. So if you don't know how to get the internal API documentation yourself, or you don't have access to read the code, you're kind of on your own on this one. So if you ask me how to do something that's not on the public API, I'm not really going to be able to help you. I might, however, send you to the correct team to ask them. And whether they help you or not is up to them. So just understand, there's a client for you that you're welcome to try if you want, but I'd recommend you get a handle on the public customer API first, like especially if you have a test account to use. Log into your test account, play around with your test account, understand how that works as a customer, because there are a lot of limits on what customers can do, but there's not a lot of limits on what employees can do. So an employee can make a bad API call that actually impacts the database, whereas a user probably couldn't do that. So just be aware of that anytime you think you want to use the internal API for something. Okay, so getting help. There's a Confluence escalation page, which kind of does a okay job about breaking up which areas of the API go to which dev groups. And that's a good place to start if anything is broken, right? So if you want to know how to do something, however, I have a Slack channel, #SLAPI, where you're welcome to come in and ask any question you want, and I'll either do my best to answer it or direct you elsewhere to get your question answered. Just understand that I do only work 9 to 5 Central Standard Time. Anytime you have a how do I do something type question, that's a great place to start. If something is broken and something's down, something's not working right, I'm usually not the person to go to. Yes, this presentation will be shared. I'm recording it. I'll publish the recording somewhere, and I also publish the slides somewhere too. Probably I'll put links on the Your Learning thing for you guys to check out. Okay. As for things that I do fix, anything that's on SLDN that's not right, I can fix that. Anything SLCLI, if the SLCLI is giving you errors or IBM Cloud SL is giving you errors, I'm definitely the person to start off with those problems. Like it might be an API problem in general, but if it's a code issue, I can fix the code issues on these two projects. Okay, and last thing, if you want to contribute, and if you're bored at work for whatever reason and want to do some code, I absolutely love taking pull requests on any of my projects. So if you like doing Python, the SLCLI, if you like doing Golang, the IBM Cloud CLI is written in that. SLDN is all written in Markdown, so you can do pretty much whatever you want there. So if any of these tools basically don't do what you want, obviously create an issue for me or let me know about it. But if you want to fix it yourself, I highly recommend doing that too. Okay. And with that, that's the end. We've got 1 minute left. If there's any questions, let me know. Otherwise, I will do my best to publish the recording and the slides at some point today for you all to read over or go over again if you need to. All right. And with that, I think I will let you all go and have a good day. And thank you for listening to me.